welcome our presenters. Jesse Flot is the co-director of the Carnegie Mellon Robotics Academy, and Catherine Porter is a curriculum developer at CMRA. They study how educators can use robots to teach computer science, science technology, engineering, and mathematics, and develop research-based solutions that are classroom tested and foreground CS STEM concepts. So welcome to Catherine and Jesse, and I'm going to pass the presentation on to Jesse now, and so that she can share her screen with us.
Thanks, Phil, for that introduction, and you pretty much took our first slide, saving us a little bit of breath there. But yeah, thank you so much for joining us. Catherine and I come to you from the Robotics Academy. We are a research development and outreach group within the university. And so we try to use these robots that we all love to help students reach meaningful learning outcomes, whether that's in math, computer science, computational thinking, engineering. We try to study all different cool kinds of things that you can teach with those. All right, Catherine, next slide, please.
Yeah.
Our mission statement specifically is to use the educational affordances of robotics to create CS STEM opportunities for all learners. So we want to make sure that much of what we do, everything that we do, is equitable and accessible to students everywhere. We have programs that focus on K-12 education as well as early workforce development. Our curriculum is used by thousands of schools internationally. And we've had the opportunity to work with over 3,500 wonderful trainers, helping them to reach these meaningful learning outcomes with their students, helping to support them with big ideas and troubleshooting, not just the mechanics of the robot. And we do offer an awful lot in terms of support for both in-person and virtual learning. Much of what we try to offer the world is research-based curriculum. So we are not content to just put a lesson together, put it out there, and hope for the best. We work with tons of students. We work with tons of teachers, schools, teams, to make sure that all of the materials, all of the curriculum, all of the tools that we produce are tested inside of classrooms, tested inside of schools, and help students to reach those outcomes that we keep on talking about. We've had the opportunity to study those under a number of projects. One of those has been under the National Science Foundation, where we have seen learning gains increase in computational thinking and proportional math. Again, a big part of what we do, though, is also around the workforce development area. So we are located in Pittsburgh, Pennsylvania. Pittsburgh, Pennsylvania is the robot capital of the world. Tons and tons of companies are designing robots, are using robots, are starting to use them in things like advanced manufacturing. And so one of the studies that we did was learning what are the pieces of knowledge, the skills, and the attitudes that someone needs to be a successful robotics technician. We learned this from industry by interviewing employers, but also by interviewing other technicians. You know, what are the skills? What are the things that you want your teammates to be able to do? What are the things that you need to do day in and day out to be successful? And from that, we came up with a set of 5 courses. We call this SMART. That teach the fundamentals around robotics. Those are electrical foundations, fabrication foundations, mechanical foundations, software foundations, and robotics integration. So those are some big things that are needed in industry to prepare workers to work in these fields. And what's really cool, though, is we partnered with FIRST. to be able to demonstrate that students who compete in things like FTC and FRC actually learn these big ideas just by being part of the team. So we have this curricula on our website, which I'll talk about soon, totally and freely available. But also, if you have students that are in FRC and FTC, they can earn these credentials just to reflect the things that they've learned by uploading their evidence. So they can upload code that they've written, video of their robot driving around, pictures of their robot to demonstrate, yep, I know things that are inside of the mechanical foundations, which is a industry valued micro-credential. Next slide. The website that I've mentioned, where we use to deliver our K-12 curriculum and also our workforce development curriculum, is cs2n.org, or the CS STEM network. So if you are looking for high quality research-based industry-backed curriculum, this is a website that we maintain ourselves. It's a learning management system. And so you are able to make groups with your students, add curriculum to those groups, and then track your students' progress as they work through. And access to that website, access to all of our real world robots, whether it's the smart stuff or the K-12 stuff, all of that is freely available through our CS STEM network. So definitely check that out if you're looking for resources to use with your classroom or with your robotics team. A big part of what we do is we do offer teacher professional development, both for in-school teachers as well as for out-of-school, like coaches and mentors. We've had the opportunity to travel all around the world, but we also offer training on-site and online. Catherine this past summer led training for Spike Prime. And actually, we're spinning up some online training this week. We're starting another cohort that will run through the fall, covering covering EV3, covering Spike Prime. Our robotics training courses, one of them is called Coding and Computational Thinking with LEGO Spike Prime. As its name suggests, it uses the LEGO Spike Prime to help students reach those learning outcomes in coding and computational thinking. It is built around the new Scratch block-based programming environment. We estimate that it's 36 PD hours. So if you come and visit us in Pittsburgh, we spend 4.5 days together learning those things. But whenever it's online, we meet for 5 2-hour sessions, and then there's some independent study. And then we have fully virtual options that are available. We have virtual solutions for the RoboCamp, which we're about to check out soon, and we'll be unveiling a full virtual option that aligns with our curriculum as well. And then likewise, if you're out there and you're still using the LEGO EV3, we've got tons and tons of resources. We've got support for both the Scratch-based environments and the EV3G icon-based environment, the same training and virtual tools available. All right, I see a question came in from Anitha. Thanks for that question. Where can I find information about kids joining the cohorts? Sure, so Catherine, if you could go back just one slide. Sorry, one more slide to the CS2N one. I lost track. So the best place to go is cs2n.org. There's a ton of information right at the front of that page. And there's a curriculum link right at the top. You can check out all the curriculum that we've got freely available. We also have tutorial videos in there to help you get started. So if you're not sure how to make a group, how to add your students to the group, all those kinds of things, we've got a getting started section on the site that is very step-by-step showing you how to get started with all that good stuff. All right, Catherine, feel free to bounce back. Thank you.
Yeah, I think, were you done with this slide?
Yep, it's all yours.
Okay, Hi everybody. Before we get into the nitty gritty of the workshop, I'd like to take a little bit of time to get to know you and each other. So I'll send this link in the chat, or you can scan this QR code, which will take us to Padlet. Padlet is just a type of collaborative board where we can share the answers in real time. So when you get there, I want you to answer these questions. What do you do? So are you a teacher? Are you a robotics coach? Or are you a student? Where are you from? And how long have you been in FLL? So I'll just send this in the chat, or again, you can use that QR code. Okay, hang on. Funny, my keyboard's not working.
I can paste it into the chat if you need, Catherine.
Okay, yeah, for some reason my keyboard's not working.
I got your back.
Okay. Okay, you should see the Padlet wall by now.
Just to give a little bit of guidance, to make a note, you click on the pink plus in the bottom right corner, or the pink circle with a plus mark.
Yeah, thank you, Jesse.
Sure.
There's some layering on top of each other, so I'm just going to move them.
It's
All
really
right.
cool.
Yeah, so it looks like we have a student from New York City, a volunteer from Pittsburgh, a robotics coach and parent from Austin, Texas, a computer science teacher, and grades 1 through 5, robotics coach, FLL coach from New Jersey. So nice crowd we've got going on here. I see somebody typing, so I'm going to give it one more minute. All right, and we have a student from Houston. So hello, everybody, and it is nice to have you here. Let me go back to our PowerPoint slides. And we can move on. So in our workshop today, we will be going through RoboCamp, which is an informal curriculum that teaches programming, robotics, mathematics, and other STEM concepts at an introductory level. And what we mean by informal curriculum is that it's perfect for something like summer camps, workshops, after school programs, and class specials. RoboCamp, it includes virtual environments so that students can follow along from anywhere around the world. So while I'm here in Pittsburgh, Yins guys, wherever you are around the world can complete it too, and at your own pace. And sorry for those of you who don't know, Yins is a Pittsburgh slang for you all. It's kind of like our version of y'all. So let me move on. So RoboCamp is designed with carefully scaffolded activities. Each lesson is designed with a use, modify, create method. So you will see whenever we go through it, we give you a program to run, ask you to modify that program, and then you can create your own program. And this all takes place on virtual tables that look like an FLL table. And for fun, after each challenge comes a moon level that is very loosely structured and open-ended. We give an objective, but you can roam and use your skills that you just learned however you want in this moon level, which is super cool. On the moon levels, you can choose how to remix the new concepts, explore, you can create messages, and you can even send moon rocks flying across the ravine. So we can get you started in CS2N. All we have to do is give you some credentials. So Jesse and I will take a few minutes to let everyone know what your credentials are. And we will get started with RoboCamp.
Yeah, so if you could, be patient with us for just a little bit, but if you wanted to in your web browser, assuming that you're on a PC, a Windows PC, a Mac computer, or a Chromebook, if you're on any of those three, you'll be able to follow along with this next bit. We would like to give you complimentary access to the RoboCamp. This is one of our premium products, but just for being along with us today, we want to give you premium access to our RoboCamp. So what I'm going to do is I've pre-generated some user accounts. So you do not have to go to CS2N and make an account. I've already made some that have access, and I'm going to give you those credentials. I'll just run down the participants list and do so. And if you're following along with the recording, if you're watching this later, feel free to reach out to me. Our contact info is at the very end of the presentation. Feel free to reach out to me and we'll be able to extend that same complimentary access to you. But yeah, hang with us for a couple of minutes while we share each of those individually, and then we'll pick up in a way that you can play and follow along and have some fun with us. And if you have any questions, don't hesitate to fire away.
I'm on a phone, so how do I get to this website? Do I just do the same thing? Because you only listed PCs
So,
as a way to get there.
You can get there using your phone if you go to cs2n.org, but the virtual simulation, you do have to have a keyboard to be able to use it. And so I'll give you username and password for our CS2M website, just like everybody else. You can check out the curriculum, but whenever you want to actually use the simulation, you'll want to be on a Windows, PC, a Mac, or a Chromebook. So save that for later. If you have one handy, maybe you can one over.
Wait, so I can just can just write the information down and then just put it on my PC later?
Yep, absolutely.
Okay.
It's
All
just access to a website. Okay, and a question from Anita. Will the simulator work on the iPad? It does work on tablet-sized devices, but we do recommend things with keyboards for the best results, for the best experience. So really, Windows PCs, Macs, and Chromebooks with keyboards are what we kind of advertise, even though you can make on other stuff too. All right, and I'm starting to send out that info to everyone now. The first thing that I'm sending you that begins with FLL kickoff, that's the username. And then the robots123 is the password. All right, Phil, would you like access to it too? To play around maybe?
Yeah, I'm more than happy to play along with everyone.
All right, I think I sent everyone some individual credentials so that we don't get our wires crisscrossed about who's who. So if you go to cs2n.org, there's a button to log in. If you enter that FLL kickoff and then the numbers into the username and then robots123 as the password, you should get right in. The first screen you might see might be to update your information. You can just hit that update information button. You don't have to change anything. That's just what happens when you, in our system, you can generate anonymous users. And so that's the first screen that you get. But as soon as you click that, you should get access to our purple RoboCamp with virtual Spike Prime activity.
How about if you can, whenever you're done signing in and you see the RoboCamp activity, you can react or give us like a green check mark in Zoom so that we know everyone's on the same page.
Okay, everyone, and I'll try to make it a little bit easier too. If you go to cs2n.org, and I'll put that URL inside of the chat box. If you click that link and then log in using the credentials that we gave you. Okay, then you can press the update, I think it's personal information button, but you don't have to change any info. and then you should be all good to go. I think that's it. Oh, and then Catherine, did you ask for the checkbox to let?
Yeah, so on Zoom, you can react with like a green check mark. So if you can, just give us a green check mark, just to let us know that everyone is on the same page.
Very good. And so that'd be in reactions. And let's see, it gives me a thumbs up right away.
Should it say something like RoboCamp Virtual Spike Prime, and then it has like a paragraph of writing?
Yep. So
Or-
if you're looking at our screen here, the bottom screenshot that we've got is a little bit small, is what you should see.
Yeah, that's what I see.
Perfect.
Hi, I'm sorry. Do I need to click on sign in or create new account?
Sign in.
Okay.
All right, starting to see some thumbs ups. Are there any other questions out there? Anybody stuck?
I think most people gave, the reaction goes away after a certain amount of time. So I think some people, or sorry, most people have given us a thumbs up or a check mark. So if it's okay with everyone, we can move forward. Okay, so I'm going to walk through the first few pages of RoboCamp. I'll walk through introducing TacoBot, the warm-up, about the Iris rover, and forward and reverse. So let me do a new share so you can see RoboCamp on my screen. This is the group that you should have joined, and to go into RoboCamp, you click the activity here, and it takes you to this page. So this first page, a letter to the educator, we don't need to go over right now. It just talks about that we offer professional development for teachers with Spike Prime. So introducing TacoBot, go ahead and go to this page. Right off the bat, you're probably wondering why we named it TacoBot. Well, once upon a time, TacoBot did stand for something, but I can't remember what it was. Something along the lines of totally autonomous, and I can't remember the rest. But in all honesty, our team just really loves tacos, and we thought it would be a fun name for a robot. So if anyone has any ideas on what the acronym can stand for, let us know, and you can type your ideas in the chat. Anyways, this is TacoBot. It is a virtual version of our physical TacoBot that we have, that our team designed. The virtual version of TacoBot has motors for wheels, an arm motor that has a linkage to the arm that's in front of the robot, and a distance sensor. All right, so the next page is a warm-up activity. So this is the first virtual activity, and I can give you a moment to play around with it. To get to the virtual activity, you just click this button. You'll see that we have, let me let it load for a second. We have our block palette on the left. We have a programming canvas with code already inside of it. We have our virtual robot window that can expand and shrink. And on the far right, we have our content page, which can also collapse if you want it out of the way. So the code inside of here is programmed to give the robot WASD controls. So W to move forward, S to reverse, D to turn left, and A to turn right. And the up and down arrows will move the arm up and down. So you can use your mouse to get different angles of the robot. Camera 1 follows the robot, and you can zoom in and zoom out. Camera 2 shows the entire virtual world at a bird's eye view. And this button down here shows the sensor. So it will show you what the distance sensor is looking at. And right now I see that this ramp is 82 centimeters in front of the robot. Up in the top, you've got your run button, refresh, and this green button is for you to start in different locations inside of the world. So right now my robot is in front of this ramp. If I click this here, I'll start at that location. So I can give you just a few moments to have you play around with it. And there is a hidden Easter egg somewhere. And if you can find it, good for you.
Just in case folks missed it, what this starter program lets you do is drive the robot around with your keyboard. So this is one of the reasons that we say, have one of those Chromebooks, Windows PCs or a Mac that has a keyboard, because whenever you press W, it will move the robot forward. S, it will move the robot backward. A is turn left and D is turn right. And so you can use the keys on your keyboard just to drive the robot around, but it's still a program that's telling it to do that. So that's one of the reasons that you'll need a keyboard for this part. But yeah, feel free to try it out, have some fun, just drive around, and then we'll get into the more serious learning stuff soon. Does anyone have any questions while they're trying it out? Surprised by anything? All right. Guess it's going well.
Yeah. I'm gonna say 6:45, we can move on. So that's 1 more minute. And it just changed. All right, so let's continue. Next page talks about the IRIS rover. So in our curriculum, we introduce robots designed at Carnegie Mellon to use as an overall theme that connects to the learning content, or that connects the learning content to real world applications. So all activities and challenges are designed and written with a narrative that aligns to the theme robot and what the robot does in the real world. So our theme robot for this curriculum is Iris, which is a moon rover. It is the size of a shoebox, and it was designed by students at Carnegie Mellon University and is actually set to go to the moon later this year with one of NASA's spacecrafts. Its mission is to explore the Lactis Mortis part of the moon. It means the lake of death in Latin, and what it is a crater that's filled with lava on the moon, which is super crazy. So IRIS is going to explore and collect data for geological sciences from this crater that's filled with lava. So that's IRIS. And now our first lesson is to learn how to drive in forward and reverse. So remember how I mentioned that we follow a use, modify, create design method? Well, here, our first virtual activity, when you open it, you'll see that there is code already in here. So we ask you to run it and see what happens. So this content page says to test it out, run it by clicking the run button, and hot tamale, I just made my robot drive forward. So your very first program done. And then to modify, in this try it activity, we ask you to modify the code that we gave you. So the instructions here are to change the distance from 10 centimeters to 50 centimeters, change the speed from 50% velocity to 75%, and then change the direction to reverse. So we just used this, now we're modifying it, run it. And awesome sauce, you just modified your code. After completing a virtual activity, if you refresh your page, you'll see that it was a gray icon. Whenever you complete it, it'll turn green. So that's why my page might look different than yours. Mine are all green because I've completed them already, but yours are probably gray. And if you refresh, it will turn green. Okay, so let's see here. We also have in our curriculum, did you knows are sections of helpful information that helps explain what you just learned. So this one talks about how program flow works, which is how the robot executes a program. And then we move on to practice your programming. And this is where you create your code. So we have step-by-step directions. So step 1 is to move the set movement speed block. You can drag it over and drop it. Add the move block, you drag and drop, and you just follow step-by-step each one and run and observe. So this is where you just create your own program step by step. So that was that one. And then we have another did you know that talks about proportional relationships and linear movement. I'm not going to get into the nitty gritty of this, but you can on your own time. It just basically talks about how you can find the distance traveled by the robot by using the circumference of the wheel. And all the way down, we have extra resources that also covers the similar topic of proportional relationships if you want to get in more into that with your students. At the bottom of the lesson, we have a mini challenge that is your type of formative assessment. So students can complete this challenge with the skills that they just learned with some requirements on specific problems. So we ask you to travel certain distances here and then reverse back to the starting point. And finally, we have our moon level, which is our open-ended, more of a loosely structured virtual activity. And we do give you an objective. So this one says to drive over the bridge. So you can drive over the bridge, can start in front of it right here. But then after that, you can do whatever you want. You can roam, try out different locations, stuff like that. All right, so let me go back here. All right, so that was our walkthrough. And now we can work for the next 15 to 20 minutes on the rest of the RoboCamp. So what's left is turning, our movement, distance sensor, and a wrap-up activity. So again, you can take 15 to 20 minutes to complete this on your own. And while you're working, we want you to share your work so you can take screenshots or videos of your virtual robot. If there's something cool that you think it's doing, you can share it on this Padlet board, or you can chat with us in Zoom on the chat, or just unmute yourself if you have any questions or have anything to discuss with us.
And if there's any questions at all, you can feel free to unmute your microphone or throw those inside a chat. Be happy to try to answer anything.
Jesse, do you mind copy pasting that link into the chat?
Sure thing. Is it a new one or the same one as before?
It's a new one.
Got it. All right, that new link is inside the chat box. Is there a question out there?
Forward and reverse. I don't think I'm sure. It is a
Everybody doing okay out there? Having fun? If you have any questions, don't hesitate to unmute yourself and ask or put it in chat.
I'm going to share the Padlet wall. There have been some uploads that are pretty cool. So for those of you who've been sharing your work, I see somebody started the final mission and did some zigzagging on the paint area. Let's see. This one. Someone hit the satellite with their launching of the rocks. I think this one does it too. So you can hit the rocks and have it go into that satellite across the ravine. There it is. And this one looks like they've captured a space box. All right, awesome job, people. Keep them coming. We love seeing these. All right, I'm gonna give everyone 1 more minute. All right, so I'm gonna bring us back. And I'm glad that some people were uploading their work onto the Padlet wall. That's super awesome. So thank you for those of you who did that. Let me go back to our PowerPoint. All right. So RoboCamp is an informal curriculum, which is great for camps and workshops and something like this. But if you are looking for a more formal curriculum for classrooms, we have coding and computational thinking with Spike Prime. We have a version that's open to the public that uses the physical Spike Prime robot and are currently still developing the curriculum for the virtual version. These are the units that are included. So we have programming the hub, movement, wait until with sensors, loops, discrete decisions. We have a capstone challenge and continuous decisions. But within these units, we don't just teach how to program. We include lessons and activities that help students build the core computational thinking concepts, such as decomposition and recognizing patterns. So you can find all those good stuff in there. And it includes videos, animations, and step-by-step lessons. Any questions on this? Will we be getting slides? I believe so. Jesse, do you have an answer to that question?
Yeah, well, so a question from chat was, will we be getting the slides to this presentation as well? We're happy to share our slides with First. I'm not sure if First has a way of disseminating. Phil would have to chime in with that part, but we are happy to share these slides.
All right, thanks, Jesse. And that's all we've got for you tonight. So thank you everyone for joining us. We were really happy to be here. Let us know if you have any questions at all about anything at all. You can visit our website at that link. And there's our email address if you want to contact us with any questions. And thanks again for making this a very fun evening. Thank you.
I'm just putting some of those URLs inside the chat box for convenience, where you can get to our information, our curriculum, and
Come on, Kobe. Come on, Kobe.
And also our email address. Yeah, we'll go in there too. Yeah, any questions at all that Catherine and I can help answer? Hope you all had some fun. Happy to be here. Anything about your experience though?
It sounds like everyone had a good time, and there aren't many questions there. I just wanted to take this opportunity to thank you both for taking the time to show us this awesome program and the educational materials that you have at Carnegie Mellon, and really appreciate you sharing that with us today.